Hey, hello guys, and welcome to another video by NetGain and myself Arijit. And today we are going to look at the oxyhemoglobin dissociation curve. So this is basically a very important topic from the exam point of view, and a lot of students find it a bit confusing. So let me make it a bit easy for you. Okay, so let me first draw the oxyhemoglobin dissociation curve for you. So in this x-axis you have the partial pressure of oxygen, okay, and in y-axis you have the saturation level. Let me put it as percentage. So that means how much or what percentage of hemoglobin inside the blood is actually bound to the oxygen, or it is saturated by the oxygen. Now the curve look like this. It's basically a sigmoid curve. Okay, so it is not straight line because you have a cooperativity between the oxygen hemoglobin binding. Okay, so you may know that. Now from the point of view of dissociation curve, so it is said dissociation because let's say this is 100% saturation at this partial pressure of oxygen. Now if you drop the partial pressure of oxygen or the oxygen tension, your saturation will go down. So that means your hemoglobin will dissociate from the oxygen. Okay, so at this range there is a sharp increase or decrease, then it goes slowly to the saturation or it goes slowly to the zero line. Okay, now questions generally come from the right shift and left shift, and what are they? So let me just change the ink. So now for a moment consider this curve just as a curve per se. So if you go to this side, this will be your right shift. Okay, so the curve will look almost similar, but it is shifted to the right side. So this is, let's say, normal curve, and so this will be your right shift. Okay, now let me change the ink again. And now if you go to this side, okay, so this will be your left shift. The curve will look mostly similar, but it will be a bit more steeper. It will be a bit more steeper because you are going to the left side. Okay, as you will be going to more close to the y-axis, the curve will go steeper and steeper. Okay, now so this will be your left shift. Now how this left shift and right shift works and what are the consequences? So let's consider this as a 50% saturation. Okay, now to get this 50% saturation, you have to have, let's say, this amount of oxygen partial pressure or oxygen tension. Now this is for the normal curve. Okay, now for the same oxygen partial pressure, if you go to a right shifted curve, your oxygen saturation decreases, as you can see. Okay, so whenever you go to a right shift, the curve goes to the right side, your saturation level decreases. And if you go to the left side, you have to sorry, let me just draw this again. So now if you go to the left side, your saturation level, as you can see, it increases. So your left shift actually increases the saturation level. Okay, so this is from a very physical, I'm talking from the very physical aspect of these curves. Now, why this left shift and right shift happens? So the right shift happens for several reasons. One of the reason is increase in temperature. Okay, another is increase in CO2, or this increase in CO2 and this the right shift means more and more dissociation of hemoglobin from the oxygen, or less hemoglobin is saturated with the oxygen. So this increase in CO2 partial pressure and dissociation of hemoglobin from the oxygen is called actually the Bohr effect. Okay, and this increase in CO2 also means increase in H plus, or the increase in acidity inside the blood. Either or, it shift the normal curve to the right side. Okay, there is another important factor for this shift, is that increase in 2,3 BPG, or some people call it 2,3 DPG. Okay, now this is a compound which actually causes which actually lessens the affinity of hemoglobin towards the oxygen. Now I am not going to the details of BPG, how it is produced and how it works. I'll be covering it in another video. For now, just remember this, that 2,3 BPG, because it reduces the tension, the association of oxygen with the hemoglobin. So for a right shifted curve, you have increase in 2,3 BPG, and for the left shifted curve, you have exactly opposite of these things. So that means in decrease in temperature, decrease in CO2 or H plus, and decrease in 2,3 BPG. So this is, I am considering at a particular altitude. Okay, here altitude is not changed. So let's say at a ground level I am talking about it. So now let's consider if we are going up. Okay, let's say this is the ground level and we are going up. So the height is increasing. So we know that when height increases, okay, let's say we are climbing a mountain, the air gets thinner, or the oxygen level decreases. Okay, so in that case, if you draw the curve again, this is saturation and this is your partial pressure of O2, and you have your curve like this, somewhat like this. And so for, let's say at ground level, this is your partial pressure. Okay, so you will have a saturation like this. So this is, let's say this is your partial pressure. Okay, now if you climb a mountain, or if you go to a higher altitude, your oxygen partial pressure decreases. So let's say now at this height, your oxygen partial pressure is this. So for the same curve, if you draw the line again, you see for this reduced oxygen tension, your saturation decreases. So from this curve also you can explain, when you go to a higher altitude, your oxygen availability decreases, and so your hemoglobin and oxygen binding is decreased, because there is less oxygen available to bind to the hemoglobin, and so the oxygen saturation decreases. Okay, so these are the basic things that you need to remember, and don't just mug up all these things, just understand the basics of these concepts, and then you can answer any question from oxygen hemoglobin curve. So now let me discuss one question with you, and this has been sent to me by one of my students. So it is saying that during Spanish conquest, the Inca Empire at the high altitude in Peru, many soldiers fell sick. So this is actually saying there is a high altitude issue. Okay, it was found that sickness was due to low partial pressure of oxygen in the atmosphere at that altitude, which I already discussed. And to determine the reason, blood was collected from those patients, and then the circulating erythropoietin levels were estimated, and the O2 is also estimated, and this O2 dissociation curve of hemoglobin were drawn, and then you have 4 conditions or 4 type of figures, and you have to choose which 2 are correct. Okay, so now this erythropoietin, let me tell you, for those who do not know, this erythropoietin actually promotes the RBC production from bone marrow. Okay, now these patients are those soldiers who actually went to a higher altitude. So for the native people, because they were living at that higher altitude for a long time, for many generations, so they were accustomed to the higher altitude, so their oxygen hemoglobin dissociation curve is normal. Okay, for patients there is a right shift. Sorry. Yeah, so sorry, I was saying it correctly. So for patients there will be a right shift because there will be less oxygen available, and so let's say for patients to get, let's say, normal amount of oxygen tension, you have to have this kind of a oxygen partial pressure. Let's say at ground level this partial pressure was there, but when these patients went to the higher altitude, let's say at this stage, your native will have more or less this high amount of oxygen saturation because they are accustomed to that situation, but the patient will have a low amount of oxygen saturation. Okay, so you have this one correct and this one not correct, because then it is showing that patients have the left shift, which is not possible because patients will have, or those soldiers will have less amount of oxygen saturation when they went up to that high altitude. Okay, so A is correct. And for the erythropoietin, now there are many ways to counteract this kind of high altitude problem. So natives can have many kind of acclimatization in their body or the modifications in their body. So one of them is that high amount of erythropoietin. Okay, so you have high amount of erythropoietin in the native, and so for that you have high amount of RBC in the patient's body. In native's body. So you have high amount of hemoglobin, that means inside their blood. So with increasing the RBC or say hemoglobin, they can cope up with the low oxygen partial pressure. Okay, so because they cannot increase the oxygen partial pressure, so they are increasing the molecules that can bind to that oxygen, low oxygen. Okay, so in this case then you will have this is a native. So native are having higher amount of EPO or erythropoietin than the patients. So you have C correct. So A is correct and C is correct. So that means this option 1 will be correct. So you can expect this kind of questions in your CSR exam or say DBT or GATE exam. So don't get confused, just think logically like this and you will be able to easily answer this kind of questions. Okay, so I hope you liked the video, and if you have liked the video, then please like the video in the YouTube or in Facebook. And then if you are new to our YouTube channel, then subscribe to it, or if you are watching it in Facebook, then please like our page. And you can also join our regular courses. For that you have the contact number, you can contact us via WhatsApp or you can just call us. And this is for today, and we'll come up with another video sometime soon. Okay, bye.